guys, so we have this equation in front of us, and what exactly is this equation? Well, this equation is the definition of a definite integral. Well, that being said, that doesn't really tell us what exactly this equation means or what it's telling us. Well, what this equation is telling us is that for any function f that is defined from a to b, we can create an n amount of intervals that has an equal width of delta x for an infinite amount of subpoints. So with that in mind, let's look at the variables and what they exactly are. For delta x, we have that is equal to b minus a over n, which is just your your ending value minus your starting value over the amount of intervals that you have. For this case, since we have an infinite amount of intervals, we just leave it as n. For x sub I, it's equal to a plus I times delta x, which is just your starting value plus I times your width. So with that out of the way, let's look at this graph. So what this graph says is that we have an n amount of rectangles, and each of these rectangles has a width of delta x. So if we add up all these rectangles together, we can get an accurate estimate of what the area under the curve is. Under this curve. Under this curve right here. So, but if we use an infinite amount of intervals, we can get the exact area under the curve. So that's what we're trying to go for. Alright? So when we use a limit to evaluate a definite integral, we need to know how to work with sums. So the following three equations here give formulas for sums of powers of positive integers. So for example, I is equal to n times n plus 1 over 2. So the sum of I squared is equal to n times n plus 1 times 2n plus 1 all over 6. And I like to expand it over here, so it's a lot easier to work with when we're trying to evaluate the problem. And the last one is I cubed, which is equal to n times n plus 1 over 2 all squared. So this is an integral part, pun intended, in using the definitive integrals. But I'm assuming that you've already learned this because this is the basic part of the definite integrals. So just know that you have to memorize these because when it comes up in your tests or your AP Cal College board tests, they won't give you the formulas, and you'll just have to memorize them yourselves. Alright, so moving on to the good stuff. So we have the integral from a to b of f of x is equal to the antiderivative of f of b minus the antiderivative of f of a. And I know this is not part of the definite integral part of the video. This is more of the fundamental theorem of calculus, but when we're talking about the definite integrals, this has to come up as well. So basically, I would like to tell you guys to interpret this as the difference of areas rather than the area underneath the curve. Because, for example, looking at this graph, we have negative area here and positive area there. So, with that being said, f can be both negative and positive, while area can only be positive. So, when you're calculating this into your equations, use the difference of areas instead of the area underneath the curve interpretation, because that makes a lot more sense and a better justification inside of your head. Alright, so moving on to the midpoint rule. So the midpoint rule is similar to the right hand and the left hand rule where you're using rectangles to find the area underneath the curve, except for this one, for this case we're going to use x values that are in between the original x values that are given to us. So for this example, if we have 1, 2, and 3, each with y values of x, y, and z for the function, using the function as our base, then 1 to 2 we would use 1.5 instead, and 2 to 3 we'd use 2.5 as our x values for the midpoint rule. So just know that, so when you do go into when you see the midpoint rule, that you know you just have to take the value in between each original given x value. Alright, so let's go to the properties of integrals. So for our integrals from a to b of c dx, where c is our constant, it's just c times b minus a. And moving on to the next property, for the integral of a to b of f of x plus or minus g of x, it's equal to the integral of a to b of f of x plus or minus the integral of a to b of g of x. So basically, we're just splitting up the equation. And including this property and the few properties that we're going to go on in the next few moments here, is that learning how to use these properties to manipulate the definitive or the definite integrals makes it a lot easier to handle more complicated problems. So knowing how to use these to manipulate this certain equations or certain types of problems can be a really good advantage for you during a test. So let's go on to the next property, which is the integral from a to a of f of x is equal to 0. So no matter how complicated the function of f is, if its lower bound and higher bound are the same thing, then your answer will be 0. So from a to a, it's equal to 0. All right. So the last property of integrals that I would like you to know is that from the integral from a to b of f of x is also equal to the same thing as negative 1 times the integral from b to a of f of x. And this is true, or rather than this is true, you want to use this because we're assuming more than 99% of the time that b is greater than a. That's why we go from a to b. But in cases where b is less than a and a is greater than b, we want to switch it around so it doesn't go from the higher value to the lower value. We go from the lower value to the higher value. And when we do that, we always add the negative sign outside in front. So let's just go over some few common mistakes that a lot of people seem to have. It's not taking the antiderivative. And I know this feels like a small small thing. It's nothing too big and like ridiculous, but when it actually comes to a lot of the points missed, a lot of students interpret this part of the equation as f of b minus f of a. And that's definitely not what you guys want to do. So just be careful about that. Regardless if it's small and it seems ridiculous, it's still a problem that some students overlook. All right. So the next one is forgetting to add the negative sign when changing intervals. And as already stated, you have to add this negative sign here when you're changing the order of intervals. So regardless if it's going from higher to lower or lower to higher, when you're changing the order, you always have to have a negative sign. And the last common mistake that we have is using the wrong sum formulas. You know, that thing that we talked in like the first 2 minutes of this video? Yeah, so a lot of people like to use certain formulas for certain other things. So you see these two formulas here, they're quite similar. There's just that squared sign outside that changes the two formulas from each other. So a lot of people sometimes mistake the I formula for the I cubed formula and vice versa. So memorize these, get a good hold of these, and if you do, you have no problem. If you won't have a problem on certain problems that ask for the use of some formulas. All right. So let's just do some examples to get this locked in. So for the first example is the integral from 2 to 6 of x over 1 plus x to the 5th power. And remember, do not evaluate. Just set up the integral as the limit of sums. All right? Just pause the video, do it. If you think you can't do it, then we'll just go with the solution and see if you understand that. So just go ahead and pause it if you're going to work it out. All right, so I assume that you guys have paused the video, and the answer for this is right here. It seems long, but it's actually pretty short in terms of the solution. So our equation is f of x is equal to, or our function is the f of x is equal to x over 1 plus x to the 5th power. Our lower bound, which is 2, and our higher bound is 6. So we have a equals 2 and b equals 6. We find delta x first, which is b minus a, 6 minus 2, 4 over n. So it's equal to 4 over n. X sub I is your starting value, 2 plus I times delta x, which is, 4 over 4i over n. So now that we have x sub I, we can go ahead and plug that value into our equation. 2 plus 4i over n, all over 1 plus 2 plus 4i over n to the 5th power times 4 over n. So that's the standard format of that equation, or setting up the limit of sums. All right. Something I forgot to go over earlier was the displacement and total distance ideas. So The displacement and total distance will come up in a lot of the FRQs for the AP Calc AB and BC problems, and these will be either your number 2 or number 3 problems because they either require a calculator some of the time or they don't require a calculator for the other half of the time. So what exactly is displacement? Well, displacement is where you've ended up after a certain amount of time, and this will usually be your velocity function, because the antiderivative of velocity function is a position function. So keeping that in mind, the total displacement will show you which position you've ended up in the end. So that's for displacement. But for total distance, you take the integral from a to b of absolute value of f of x. So even if you go back in distance, like back, you got a negative value in distance, you still have a total value, positive value of how much distance you've traveled. And once again, that will be your velocity function. Alright, so let's go over our last example. So the example is that given that the integral from 6 to negative 10 of f of x d of x is equal to negative 23, and the integral from negative 10 to 6 of g of x dx is equal to negative 9, find the integral from negative 10 to 6 of 2 times f of x minus 10 times g of x dx. So pause the video and try to solve it. Alright, so here's the solution. So what we're going to do first is split the equation. So let's split the integral. So once we split the integral, we can work with both functions as a separate entity. So now that we do that, we just factor out the coefficients. And if you see closely, the order of the integral on f of x is wrong. So we just factor out a negative, or we put in a negative and switch the order so we can get it to where we need it to be. So it becomes negative 2 times the integral from 6 to negative 10 of f of x. And once we do that, we can solve, and that becomes 44. So thank you guys for watching this video. And if you have any questions, leave them in the comments, and I'll try to solve them. Thank you.